Hello viewers, welcome back to class. I'm super excited to welcome you guys back to class again. You are welcome to Master Builders Online Academy. So if you are visiting this page for the very first time, do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell for more exciting videos when we upload it. Guys, don't forget to like this video, share this video, and make your necessary comment. Now, for your own advantage, guys, do not skip any part of this video. This is for your own advantage so that you will not skip the vital aspect of this lesson since we are using shortcuts. Now, also, anytime you are set to watch and to learn new concepts from this platform, do not welcome any form of distraction. Ensure that you pay maximum attention so that you'll be able to gain everything that we upload here maximally. And finally, if there be any part in this video you do not understand, when you watch it for the very first time, you have the opportunity to replay the video over and over again until you understand it. Yes, you can understand it. And that is the reason why the lessons are coming in video format. But if at the end of watching this video over and over again, you still have not understand the concept or you have some questions to ask, guys, don't hesitate. Just slide down to the comment section and document your questions. Guys, we are good at answering questions. So we will put answers to your questions with immediate effect. If this is taken, guys, let's get to the business of the day. Now, on the board, we have integration of trigonometric functions. Like we explained earlier, we are integrating functions, integration of functions. So we are taking these functions one after the other so that you will understand. We don't want to mix them up. We are taking them one after the other. So in this lesson now, we are integrating trigonometric functions. Now, when I integrate trigonometric function, what is my expected result? If trigonometric function is the only function that I have, how do I integrate trig function? All I need to do anytime you are integrating trigonometric function is to identify the trig character, whether you are given sine, cos, tan, sec, cosec, or any other trig identity. That is number one. Two is to also identify the angle of the trig identity, the given angle. So if the angle is x, you know what to do. If the angle is 2x, you know what to do. If the angle is 3x, you know what to do. Now, when the angle is 1, you don't have much to do. But when the angle is more than 1, something happens. So the first thing you do is to identify the trig character, whether you are dealing with sine, cos, or that. Then second, angle of the trig function. And this angle is always a function of x. So any function of x that you are given must be differentiated. So when you identify the angle, which is a function of x, the next thing that you do is to differentiate that function of x. Once you differentiate it, whatever you have, take it as 1 over and then integrate the trig function. So you only differentiate the polynomial function, or which is the function of x, and then integrate the trig identity. If this is understood, let's look at these examples that we have before us. On the board, we are asked to integrate, number 1, y is equal to integral of sine 3x plus 5 dx. Now, this is trig function. Now, this is the angle. 3x plus 5 is the angle of the sine, just the same way I have sine theta. Then if I have sine 5x plus or 3x plus 5, that means theta is equal to 3x plus 5. So this is the angle. What you have enclosed in the bracket here, which is the function of x, is the angle of the trig identity. So now, if this is understood, all I need to do here is to bring out the angle, which is 3x plus 5. When I differentiate 3x plus 5, I will have 3. When you differentiate 3x, you have 3. When you differentiate 5 with respect to x, that gives you 0. And this will have given us y is equal to whatever you have, 1 over whatever you have. Sine, then integrate 3. When you integrate sine x, you have negative cos x. And when you now integrate this, which become 3x plus 5 plus c. This is the answer. Y is equal to minus 1 over 3 cos 3x plus 5 plus c. This is the answer to this very question. It's as simple as this. Now, let's look at question number 2. We are given that y is equal to integral cos 2 minus 7x dx. Now, when we look at this now, this is a trig function which has an angle 2 minus 7x. So the angle is 2 minus 7x. Then I put down the angle 2 minus 7x. Now, when I differentiate 2, I have 0. When I differentiate 2, I have 0. And when I differentiate minus 7x, I have minus 7. So 0 minus 7, this will give us minus 7. So I will take this as y is equal to minus 1 over 7. It must be a reciprocal of what you have. When I integrate cos, I have sine, positive sign. Then repeat the given angle plus c. Don't forget, anytime you integrate, you must add a constant. This is it. It's as simple as that. Now, what happens if I have 3? Number 3, we have y is equal to integral of sec squared 2x minus 1 or dx. This is sec squared as secant, as the trig identity that we have here. The next that we do is, what is the angle of the trig identity? 2x minus 1. 2x minus 1. When I differentiate 2x minus 1 with respect to x, I have 2. All I need to do, y is equal to 1 over 2. When you differentiate sec squared, you have tan x. When you differentiate sec squared x, you have tan x. So when I differentiate this now, I will have tan of the angle or the x. This is as simple as this. Very, very simple. So guys, if you have not subscribed to this YouTube channel, please subscribe. It is very free. It is free of charge. It will not take anything from you to subscribe and to turn on the post notification bell if you want us to notify you anytime we upload my video content. Now, let's look at question number 4. We have y is equal to tan 5x. Now, integral of tan 5x dx. We have y is equal to integral of tan 5x dx. Guys, how do we solve this problem? Very, very simple. All you just need to do is to identify this is a trig function. Why this is what the angle of the trig identity. Now the angle here is 5x and it must be a function of x. And now what do you do to this function of x? You differentiate this with respect to x. When you differentiate 5x, you have 5. Now if this is understood, the next thing you do, since I cannot integrate tan x, how do I integrate tan 5x? All you need to do is to convert tan 5x to its equivalent trig identity. Of course, you know tan x is equal to sine x over cos x. This is what we are going to use. Then we have this as y is equal to integral of sine 5x over cos 5x dx. Anytime you are given a tan of any function and you are asked to integrate, you must convert it to sine over cos with respect to the given angle. With respect to the given angle. So I will have the sine of the angle over the cos of the angle. So this is it. I have to replace tan with its equivalent angle in sine all over cos. Otherwise, you cannot integrate it. Then if this is understood, how do we now integrate this? Of course, now we have a fraction. And anytime you have a fraction, there is one method you always choose to use, except that method will not work. What is the method? Substitution method. And how do you use substitution method? In substitution method, you pay attention to the denominator. How do you pay attention to the denominator? All you just need to do, check. If I differentiate the denominator of this function, will it give me the numerator? Yes. If I differentiate this now, it will give me the function that I have at the numerator. This is integration of by substitution. So if I understand that this integration by substitution will work, all I need to do is listen carefully, because this is shortcut, is to take this as u and do all of that. Now listen, now that we have sine 5x over cos 5x, and I know that if I differentiate cos 5x and we have this, all I need to do here, my answer becomes 1 over the coefficient sine of the denominator. Now look at what happens here. Put down the denominator, which is cos 5x. When you differentiate cos 5x, you have negative 5 sine 5x. All you need to do is to differentiate the denominator. And when we differentiate cos 5x, this is what we have. Are you there? This is what you have. Now that we have differentiated this, now listen carefully. The final answer to this question, what have you not seen? Y is equal to 1 over the coefficient of sine 5x. Because this sine 5x, we cancel this sine 5x. I don't want to show all the processes. Are you there? We are not showing all the processes. We are using only shortcuts. So all I need to do is to what? Divide this by this, leaving only the coefficient behind. So we have 1 over the coefficient, and this happens to be minus 1 over. Then the ln of the denominator plus. This is the answer to this question. So anytime you differentiate the denominator and it gives you exactly the function you have at the numerator, then the answer becomes the ln of the denominator with the coefficient of whatever you have when you differentiated the denominator. This is it. Now, if you still have not gotten this in details, you will understand this better when we look at question number 5. Now, let's solve question number 5. Now we have y is equal to integral of cos x dx. And now, all we need to do is that there is no way you can integrate cos 2x with respect to x directly. Similarly, there is no way you can integrate cot x. So we cannot integrate cot 2x directly. So what do? I need to convert cot to its equivalent trig identity that I can integrate. And we understand that cot is the inverse of tan. So if cot is the inverse of tan, then cot is equal to what? Cos over sine. Now, I will have this with y is equal to integral of cos x, cos 2x, over sine 2x dx. Since the angle here is 2x, the sine will be 2x, the cos will equally be 2x. Now the next thing I do is, this is a fraction. Quotient, right? Now anytime I have a quotient, all I need to look out for is the denominator. Now this is the denominator, which is sine 2x. Now if I differentiate this denominator, will it give me the numerator? Yes. It will give me the function I have at the numerator. So if this is understood, or if this works out, therefore, I will simply differentiate this. When we differentiate this, this will give us 2 cos 2x. So my answer becomes y is equal to 1 over the coefficient of the cos. Now remember that this cos will cancel this. Then I will have the ln of the denominator. It's as simple as that. Anytime you differentiate the denominator and it gives you exactly the numerator, the function and the numerator, the answer must be the ln of the denominator with a coefficient. And how do you get the coefficient? The coefficient is what you obtain when you differentiated the denominator, the coefficient of the outcome of the differential result. When you differentiated the function, the outcome, pick the coefficient and take the reciprocal of that coefficient. Whatever you have gives you the answer. So this is the answer to this question. So if I have y is equal to tan x or cot x, this is how they are solved. This will have given us sin x over cos x, while this will give us cos x over sin x. So when I differentiate this, I have minus ln cos x, the cost of the ln of the denominator. And when I integrate this equally, I will have ln of the denominator. This is the answer. Understand that first is to differentiate the denominator. And this will give us positive cos x. So cos x cancel cos x, then ln of the denominator. But for this, when you differentiate the denominator, which is cos x, you have negative 1. That's the reason why you have this negative here. So guys, if at this point you have not subscribed to this YouTube channel, please consider subscribing to this YouTube channel and ensure that you turn on the post notification